Okay, question 7. Okay, this is a multivariate regression. Price of the clock, I think, in an auction. Okay, the sale, the bidding of the clocks actually. It's explained by age of the clock and the number of bidders. Currently, in the sample regression function, B1 head is way smaller than B2 head. So I want to know will the same thing happen in the PRF. So you spot the keyword smaller than, so test if the PRF slope parameter of age is smaller than that of the bidder at alpha equals 5%. Okay, so new hypothesis B1 equals B2. Alternative hypothesis B1 head smaller than B2 head. Computer t-stat, numerator is easy. You substitute these two values. Denominator square root, and then square of this plus square of 8 point something minus 2 times. Again, I said covariance must be given to you. Okay, then you sort out all the calculations, square root, and at the end, your computer t-stat is minus 8.5610. Okay, critical t-stat, one-sided left tail test. Alpha is 5%. I think degrees of freedom is 30. 33 minus 2 minus 1, 30 and 5%. 5%, 30. Yeah, is it 1.697? Yeah, minus 1.697. 30 degrees of freedom. Alpha, top row, full alpha, 5%. You just have to add the negative sign, okay, to the critical t-stat. Then since the computer t-stat is smaller than the critical t-stat, new hypothesis is rejected, meaning alternative hypothesis would be more likely to happen. So B1 is smaller than B2 in the PRF. So in other words, the bidder explanatory variables will have greater impact on the price of the clock compared with the age of the clock explanatory variable. Okay. Last one, the F-test. The first one is the easiest F-test you learn in Eco 311, testing on the overall significance of all explanatory variables. I think you should be familiar with B0 and H0 and H1. We want at least one slope parameter to be different from 0. Computed F statistic equation is here. Critical F stat, and then degrees of freedoms of numerator is hiding here, k, and then degrees of freedoms of denominator is hiding here, n minus k minus 1. The formula, you don't need to memorize. It is in the formula sheet, actually. Yeah, okay. Okay, we are going to do two questions on that, and then the other F test is on the restrictions on the parameter. New hypothesis, restrictions are correct. Alternative hypothesis, restrictions are incorrect. They computed F stats. Numerator r squared of the unrestricted regression minus the r squared of the restricted regression. Later, I will explain how we can distinguish one regression from the other. It is quite straightforward. Divided by Q. Q stands for the number of restrictions imposed on the restricted regression. Denominator, 1 bracket, 1 minus r squared from the unrestricted regression divided by n minus k minus 1. And the k actually comes from your unrestricted regression. So keep that in mind. Okay. Okay, let me say k comes from unrestricted regression. Okay, then you are going to remember that. Okay. Okay, let's do question 8 and 9, the two questions on the easiest type of F-test. Marks explained by study hour, party hours, part-time work hours. I think all three explanatory variables make sense. Okay, then I would believe at least one of the slope parameters will be non-zero in the PRF. So new hypothesis, it should be easy. This is the outcome we want to reject actually. We don't want all slope parameters to be 0 because if that happens, it means the R square or goodness of fit will be 0. H1 is what we want to happen. Computed F stat, easy. R square must be given to you, divided by K, 1, 2, and 3. Denominator 1 minus R square bracket divided by N, 24, minus K, 3, minus 1 constant. So this is the computed F stat. So critical F stat alpha is 10%. Degrees of freedoms of numerator is 3. Degrees of freedoms of denominator is 20. 3 and 20. And then the F table. Okay, there are 3 F tables, so it's a bit different from the table in Eco 311. So 3 separate tables, one for each alpha. Since alpha is 10%, we have to use this one. Is it 3 and 20? 3 and 20. Then isn't my critical F stat 2.38? 3 and 20. Yeah, 2.38. Since the computer T's f-stat is way above the critical f-stat, good news, null hypothesis is rejected. Meaning H1 would happen, that is, at least one of the explanatory variables has non-zero parameter in the PRF. Good news. I think all three of them would have non-zero parameter in the PRF because all three are relevant explanatory variables. Okay. Next one, question 9. Marks explained by study hours. Number of dogs I already know it is irrelevant. Size of the garden is irrelevant, but because I commit overfitting, I don't know how it's going to destroy the goodness of fit of the regression, or the robustness of the regression. Sample size is 64, k is 3, so n minus k minus 1 is 40 actually. Okay, then I can do the F test now. Alpha is 1%. Step 1 should be fine, easy. Step 2, substitution. You already see the R square is so low actually. Then it implies there is something seriously wrong with this multivariate regression. So computed f-stat is 3.4604. Critical f-stat, 3 and 60, alpha 1%. So this is the right F table, alpha 1%. 3 and 60, then isn't it 4.13? Yeah, 3 degrees of freedoms of numerator, 3 degrees of freedoms of denominator, 60. So critical f-stat, 4.13. Okay. So computed f-stat is smaller than the critical f-stat, so we do not reject the null hypothesis. Then game over actually to this regression. Okay. Okay, happy with that? Then I'll move on to do the F-test questions 11 and 12 in connection with the other type of F-test about the restriction. Okay. Look at the first, let me rather start off with the second regression. Marks explained by lecture attendance, tutorial attendance, number of dogs, which is clearly irrelevant. Size of the bathtub is irrelevant. Then the number of cups of coffee drunk, clearly irrelevant. Otherwise, I would drink more coffee in order to pass with flying colors. Then this is clearly the unrestricted regression. And then the first regression is the restricted one, because don't you notice that number of dogs, size of the bathtub, and number of cups of coffee drunk, these three explanatory variables do not feature in the first regression. The reason is I impose 3 restrictions on the first regression, that the free slope parameters are 0. This is why they don't feature in the first regression. So I repeat, regression 1 is restricted regression, regression 2 is unrestricted regression. Using theoretical thinking, I think it is the correct decision to impose the 3 restrictions. The reason is number of dogs, size of the bathtub, number of cups of coffee drunk are really irrelevant explanatory variables. So they actually should not feature in the multivariate regression. So using theoretical argument, I actually think that it is a correct decision to impose the 3 restrictions on the 3 parameters respectively. But we have to prove it statistically. That's why we have to do this F-test. Null hypothesis is easy. Alternative hypothesis. Okay. Computed f-stat equal to r squared from the unrestricted regression, 0.91, minus the r squared of the restricted regression, 0.9, bracket, divided by number of restrictions imposed, 3 in the restricted regression. Denominator, 1 minus r squared from the unrestricted regression, divided by bracket, n minus k minus 1, again from the unrestricted regression. So 67 minus 6 minus 1. So this is your computed f-stat, 2.222. So just to remind you, coming from the unrestricted regression. Okay. Let's go back to the answers. And then the critical f-stat, alpha is 5%, degrees of freedoms of numerator is 3, degrees of freedoms of denominator is 63 and 60. Alpha is 5%, so this table, 5%, 3 and 60, then isn't it 2.76? Yeah, 2.76. 3 degrees of freedoms of numerator, degrees of freedoms of denominator 60, 2.76. And just to make sure you use the right F table, alpha is 5%. So I am using the right table. Since the computed f-stat is smaller than critical f-stat, null hypothesis is not rejected, meaning from a statistical point of view, null hypothesis would happen, which is good news. Then it means the restricted model is indeed better. So the statistical result conforms with theoretical thinking. That is, these three additional explanatory variables should not be included in the regression, meaning regression 1 is indeed better than regression 2. Okay? And then the last question. Regression 1, regression 2, let's start with regression 2, the unrestricted regression. Marks explained by study hours, party hours, whether you work or not, and whether you own a laptop. I think all four are relevant explanatory variables. But in the first regression, I only include study hours and party hours. In other words, I impose two restrictions on the first regression. The restrictions are the slope, the parameter of the work dummy is 0, and then the parameter of the laptop dummy is also 0, so that these two explanatory variables would not feature in regression 1. But using theoretical thinking, I already think it is a wrong decision to impose the restrictions, because someone's the student's work status and whether he or she owns a laptop or not, they could really have some impact, strong impact on the academic performance. So theoretically, I already think regression 2, the unrestricted regression, is better. But this is only my theoretical argument. I need to prove it. What am I doing? Okay, with a statistical test. Okay, so this is the answer. Step 1, I don't need to go through that. Step 2, computed f-stat. Numerator bracket r squared of the unrestricted regression 0.707 minus the r squared of the restricted regression 0.1375 bracket divided by number of restrictions 2 imposed in the restricted regression 1. Denominator bracket 1 minus the r squared of the unrestricted regression divided by bracket n 33 minus k 4 minus 1 constant. So this is my computed f-stat 4.0521. Critical f-stat, alpha is 5%, degrees of freedoms of numerator is 2, degrees of freedoms of denominator is 28. You can do the subtraction. 2 and 28. 2 alpha is 5%, 2 and 28. Alpha 5%, so critical f-stat is 3.34. Okay. 3.34. So since the computed f-stat is greater than critical f-stat, we reject the null hypothesis. Then it means alternative hypothesis would take place. It is correct, okay, because it conforms with the theoretical argument. We really think the unrestricted regression is better. That is, it is incorrect to impose the restriction, actually two restrictions, that the parameters of the work and laptop variables, explanatory variables are 0. Okay, so that's it for this chapter.